Okay, this is Solutions 1, the first video of the Solutions unit, and it is going to cover the topics of solutions, suspensions, colloids, and electrolytes. So we are in your note packet on the first page. Okay, solutions. First, we're going to start out on what is a solution. A solution is a homogeneous mixture of two or more substances in a single phase. Okay, the same composition and properties throughout. So what that means, remember when we talked about homogeneous mixtures back in September, it means that it looks completely the same throughout. It's not like you can see small chunks in something. It's completely spread out and it's completely mixed. It's all the same throughout the entire mixture. Okay? So a solution, when you make a solution, you have two things. You have something that is dissolving and then something that is doing the dissolving. And so you have a solvent, and a solvent is the substance that does the dissolving. An example would be water is a solvent, something that dissolves. And then you have solute, and the solute is what gets dissolved. So in our example, if you make salt water, the salt is dissolved by the solvent. The solute by the solvent. Okay? So some things about solutions, and what we're going to do is we're going to classify different mixtures as either solutions, suspensions, or colloids. So if it's a solution, the particles have to be small enough that they cannot be seen, right? And that's what a homogeneous mixture means, is that you can't see the individual particles. Okay, they have to remain mixed indefinitely, which means that they will remain mixed unless you change something like heat. But if you don't touch it, it will stay dissolved forever. Okay, and another way to tell if it's a solution, if you pour it through filter paper, everything will go through. Think of salt water. If you pour salt water through a coffee filter, you're going to get salt water on the other side. It's not like the salt is left behind in the filter, right? If you pour it through filter paper, everything goes through. Okay? And that's because when you dissolve something, the particles are going to be atoms, molecules, and ions, like individual atoms and molecules. So we're talking about sizes of 0.01 to 1 nanometers big, which is much, much, much smaller than the holes in a paper filter. So that's why everything goes through, because you're taking things down to the molecules. Nope, too far. So here are some solute-solvent combinations, okay? If you dissolve a gas in a gas, an example of that would be nitrogen and air. The air you breathe has lots of gases dissolved into the oxygen, okay? If you dissolve a gas in a liquid, that would be an example of soda. Soda is carbonated water, and that's because they dissolved carbon dioxide, which is a gas, into water as a liquid. Okay? What about dissolving a liquid in a gas? Well, that is an example of humidity. When you go outside and it feels really nasty in summer because you feel like the oppression of the heat bearing down on you, that is the humidity, and that comes from water molecules being dissolved into the air. Okay, a liquid being dissolved in a liquid would be like alcohol in water. You can dissolve ethanol in water, and that's an example of that. Also, gasoline is several different hydrocarbons dissolved into each other. So gasoline is a mixture and is a liquid on liquid solution. Okay, if you dissolve a liquid into a solid, an example would be like water and wood, or if you get like a piece of charcoal and soak it in water, the charcoal will dissolve the water into it and you have like wet charcoal. Okay, so what about dissolving a solid into a liquid? This is the most common thing and probably what you immediately think of when you think of a solution, and that's like salt water or Kool-Aid. You are dissolving something that's a solid like salt into a liquid water. Okay, and then solid dissolving in solid, an example is bronze. Like when we did that Penny Lab, you are dissolving the zinc into the copper. And so you are dissolving a solid into a solid, and it makes brass. Or bronze. I guess it's technically brass. I miswrote that. Okay, so if it's not a solution, then it is either going to be a suspension or a colloid. A suspension means the particles are suspended in the liquid. So what that means is that particles are so large that if you let it sit on the counter, they will settle out unless you are constantly stirring it. So you can think of several things of when, unless you are constantly stirring it, if you let it sit there, eventually it's going to settle down to the bottom. Okay? This is a heterogeneous mixture because you can see the particles. They are big enough to be seen. Okay, an example is muddy water. Okay, at first it looks like it's all mixed up together, but if you let it sit there, all the mud settles to the bottom, and on the top, you just have water. Okay, particles are going to be over 1,000 nanometers, so that's 1,000 times bigger than the particles in a solution. So you can see these, and that's why it's heterogeneous. Okay, these can be separated by filtration. So pour it through a coffee filter, and you can get those out again. Okay, so how about a colloid or colloidal dispersions, if we want to sound fancy? Okay, a colloid is kind of in between. Particles are intermediate in size. They're between 1 and 1,000 nanometers in diameter. They are small enough to be suspended, like a suspension, but they can stay afloat because of the movement of the molecules. They will not sink if you let it sit there. Okay, and the colloidal particles make up the dispersed phase, and the water is the dispersing medium. So it's kind of like solute and solvent, but instead we say dispersed phase and dispersing medium. Okay, and then there's something called the Tyndall effect, and the Tyndall effect says that colloidal particles, so those little particles stuck in whatever you're dispersing it in, they scatter light through a transparent medium. So water would be a transparent medium. So if we put a colloid in water, then it will scatter light at different effects. So an example of this would be colloidal gold. So you can go to a health store and buy gold that you drink or swallow pills, and it's supposed to help you stay smart and beautiful or something. Don't do it. So colloidal gold is just gold particles that are in a colloid suspended colloidally in water. And you can tell that different sizes disperse the light at different wavelengths, and so you get literally different colors depending on the size of the gold in the colloid. So this is kind of cool. It looks all pretty. But anyway, that's an example of the Tyndall effect. Okay, this is another example of a colloid. Okay, you have these water molecules, and if you see like the sun beam through a window, you can see all those little particles of dust floating around. They're not sinking, they're being held up by the movement of the air, but you can see the sunlight stream through a window because of all the particles floating. And that's an example of a colloid. It's kind of like a suspension, but they're light enough that they don't ever sink. Okay, so we have different classes of colloids. Now we're on the back of your notes. Okay, so the classes of colloids, and then you have different phases and their examples. So the first one is a sol, not solid. You can cross that out on your notes. It's sol. Okay, and that's a solid dispersed in a liquid. An example of a solid dispersed in a liquid would be like mud, like we discussed earlier, and paint. That's why you have to stir paint every time you use it again, because it might have sunk, but most of the time it won't sink. Okay, a gel is next, and that's a solid network extending throughout liquid. Okay, so like gelatin, jello, would be a colloid. Okay, liquid emulsion, that's a liquid dispersed in a liquid. Okay, and that's milk and mayonnaise. That is a liquid emulsion. Okay, there's like little chunks of proteins in milk and all sorts of other liquids that are dispersed and floating around in water, and that's what makes up milk. Okay, and you have foam. Foam is a gas dispersed in a liquid. Okay, example, shaving cream, whipped cream, any of those when you are dispersing a gas in a liquid. And then you have solid aerosol, and that's a solid dispersed in a gas. An example of that is smoke. Smoke is a colloid because there are literally little tiny chunks of smoke particles being dispersed in the gas. Okay, airborne particulate matter. That's those little dust dots that you see when sun streams through a window. And then auto exhaust, like a car engine putting out. Okay, liquid aerosol, liquid dispersed in a gas. An example of that is fog, mist, clouds, aerosol spray. Okay, so fog and mist and clouds, any weather thing, that's a water being dispersed in a liquid, or in a gas, sorry, the gas being air. And then solid emulsion is a liquid dispersed in a solid, and example of that is cheese and butter. My favorite, I think solid emulsion is my favorite. Okay, so those are the three classes of solutions and solution-esque things. And so I'm going to have you skip to the second to last page, which says electrolytes and non-electrolytes. Okay, and this is pretty short. So electrolytes. Electrolytes, when you think of electrolytes, you probably think of Gatorade, because if you've ever read anything, you notice that Gatorade is an electrolyte beverage. So what are these electrolytes and why do we drink them? Well, an electrolyte and a non-electrolyte is basically classified whether it makes molecules or ions in a solution. If you dissolve something, is it going to make a molecule or is it going to make an ion? If they make ions, they are called electrolytes. So something that makes ions, we also will find, will make electric current. So electrolyte is a substance that dissolves in water, makes ions, and also conducts electricity. So obviously, ionic compounds can make ions, right? NaCl, salts. Highly polar compounds like HCl can make ions. And since ions are charged, they can carry electricity. This is the key for why electrolytes conduct electricity, because they are charged. So if they are not ions, then that means they are molecules, and that makes them a non-electrolyte. So a non-electrolyte is something that will not electrolyte, something that will not conduct electricity. And that's because they just break into molecules, but not ions. So if you dissolve sugar in water, all it does is break down into molecules, but it will not break down into ions. It will stay a whole molecule, and molecules have no charge, and no charge means no electricity can flow through it. So, does water conduct electricity? Most of you are probably like, well, obviously, I'm not going to take my hairdryer in the shower with me because I would die. And that's good, because you would die. But water does not conduct electricity. I'm sorry to break this to you, but I am dispelling the myths of your third grade science teacher and your mom that they told you that water conducts electricity. But it's not true. So let's look at it. Water is H2O. H2O is a covalently bonded molecule that has no charge. So therefore, if you have pure or distilled water, it will not conduct electricity. So in the lab, we have distilled water. If I filled up a sink of that and then tried to electrocute myself, I would be unsuccessful because it will not conduct electricity. So then a question I know you're thinking is, then why does tap water conduct electricity then? Well, if I pour water directly out of a sink, am I guaranteed pure water? Probably not, especially not in Bryan or College Station. So tap water has a lot of impurities and a lot of dissolved ions, which are electrolytes, and they conduct electricity. So that is why tap water will conduct electricity when real water does not. Okay, so pure water, no conducting. Okay, and then I want you to click on this YouTube link, and it goes to a video of the guy kind of demonstrating this with water and salt and sugar, and showing you that there has to be ions present for it to conduct electricity, because water does not conduct electricity. Okay, so this is a kind of visual representation of what that guy did. Okay, so if you have a light bulb with the electrodes In salt water, you can tell that the ions allow the light bulb to be on. If you have no ions, like molecules, you see nothing charged, no ions, then the light bulb is off. And then if you have acid, like hydrochloric acid, you have ions again, and the light bulb is on. So ions equals electricity. If you have ions present, electricity will flow, and that's what an electrolyte is. An electrolyte is anything that makes ions. So basically, all that Gatorade is really expensive salt water. But that's okay, because I would never drink salt water, and they make it taste pretty good despite it having a lot of salt. But go look on a Gatorade bottle, and you'll see the sodium content is really high, because that's all that they're doing is just adding salt and other kinds of salts besides just NaCl. But anyway, okay, that is the end of this video. Be prepared for a quiz on Monday or Tuesday over the material, and I will see you then.